Hello, my name is Eero Laaksonen. I'm the CEO of Valohai, and I'm happy to show you around the product. But let's start with a few sentences and explanation on what Valohai is. Valohai is an MLOps platform, and we help companies that build custom machine learning models to do it a lot faster. And in the machine learning model building workflow, we focus on two major areas, those being exploration of models and then productionalization of your pipelines all the way to the deployment of models. And for those two phases, we do machine orchestration for all of your compute, but then also version control for all of the executions and experiments that you're going to be running. All right, let's get started. What you see here is the Valohai graphical user interface, but we also provide an API for all of our features, so you're free to automate everything through API calls. And like I told earlier, we do exploration and productionalization. So we're going to start with the exploration phase. And for that, we provide a few different ways to work. But the most common way that we see our customers using Valohai in the exploration phase is by using our Jupyter Notebooks extension. And in Valohai, I have created this project that is called Walkthrough. And I'm going to go ahead and show you this extension. I've installed this to my notebook. And in settings, I can select the Walkthrough project to tie this notebook into the project. We can also choose where to run. So we can run on any of the major cloud providers, Azure, AWS, and Google Cloud. And then we also provide support for on-prem hardware. So if you have a GPU cluster or something like that locally, you're able to run Valohai on top of that. And what I can do here is I can start working with my notebook locally. This is what we do when we have some sort of like small subset of data or dummy data. We can figure out the syntax for our code and make sure that everything works. But when we want to actually execute everything on a larger compute, we just click here on Create Execution. And what this will do is it will spin up a machine on the cloud, deploy a Docker image, ingest your code and data, and start running. So here we can actually see that a machine is starting to run the code. What is cool is you can actually start multiple runs at the same time, and Valohai will take care of all of the work queue management for you. So if you have a single cluster and multiple people working, starting multiple runs at the same time, Valohai will take care of all of that for you. Or if you're just individually working on larger compute and want to utilize multiple machines, it's really easy. Here I can see that I have two different machines running my code on the cloud in this case. And once the execution is done, I can go ahead and click here. And what this will do is it will get the notebook back for me. So I can see all of my outputs and continue working on the notebook. And let's say change something again and spin up a new run. So what we have here is a way to easily utilize larger scale compute from notebooks without having to like manually spin up machines or SSH somewhere or like just fully utilize a single EC2 machine or something like that with your notebook. You're actually able to like really transparently run on large compute when you need to. Secondly, you get a complete version control for all of your executions. So I have here all of my previous executions. They're stored. I can go back to them. And that additionally, if you share access to this project, anybody who has access and selects the project will get these executions, and they are able to execute them without having to think about all the complexities of like what the versions were and so on and so on. Now, if we jump back on the Valohai side, we can see that we have actually saved all of these executions. We can still see that two of them are still running, but the two first ones are done. And if I go here, I will see everything. I can see that the code was what we call an ad hoc commit, which means that it's not coming from a Git repo, but we still save the code for you. We also see all the data and parameters and so on, including all of your logs and metadata from your execution. In this case, I have accuracy and loss function. And whatever output artifacts you want to save from the execution can easily be saved, and they will be stored by Valohai automatically to your data store. In this case, where we're storing is on an S3 backend that we've configured for this project. But you can, of course, have your data backend. All right. This is the exploration phase. When our customers move to productionalization, what we usually recommend them doing is to switch over to scripts and start managing their code in version control, something like Git. And here I've done exactly that. I've taken the notebook and I've split it into a few different parts. First comes pre-processing, then comes training, and so on. So the pre-processing script takes in data, does some pre-processing on my data, and then saves data out. The training script takes in data, trains a model, and then saves a model out. And once I have something like this, all I have to do to include Valohai or integrate with Valohai is to add this simple YAML file that defines the different steps of my pipeline. And something to think about is that there's nothing Valohai specific in this code. You don't need to learn complex libraries or ingest complex libraries to your code. You're just writing code just like you would normally. All you have to do is add this YAML file. And if you've worked with something like CI/CD systems before, this is very similar to how CI/CD systems work, for instance. So here we have the step for pre-processing data. We define a Docker image that can run the code. Then we define the environment we want to run in, and then the command that we're going to be executing there. And this is just a simple command. We're going to be running just a simple Python file this time, but it can be much more complicated than that. Multiple lines of commands. And then we have the data inputs. And I'm going to be talking more about how the data flows through Valohai in just a minute. So if this looks a little bit weird to you, you'll get the hang of it in just a minute. Then we have the training step. Looks very similar. Again, a Docker image, an environment, and then a command. The difference here is that what we've utilized the Valohai parameters feature, which allows you to do hyperparameter optimization and also track all of your parameters of your executions and experiments. So here we define the different parameters, and something to understand here is that this is dynamic. So here I have epochs, learning rate, dropout, and batch size, but you can define whatever parameters are relevant to your code. And all you have to do is take the parameters in as command line parameters in the command of running your code. And this is what usually already you're doing. So it should be quite straightforward to implement this. And then again, the data inputs for this particular step. All right. Once we have this kind of configuration set up, all we have to do is copy the repo and then fetch the repository on Valohai end. And now we're ready to run executions. So here I'm going to create an execution, and here we can see all the steps that are defined in the YAML file. We looked at the pre-processing and the training step, but there are a few others that I didn't show yet. So we're going to start with the pre-processing. Now Valohai will automatically populate these fields from the YAML file configuration with your default values, but you're able to overwrite them here if you want to. And I'm going to create an execution to run the pre-processing first. While we wait for that run to go through, I'm going to show you a little bit more on the details tab. So this is where we store all of the information. Again, we say that what was the environment, what was the code commit. In this case, we have the commit version. In the notebooks version, we had an ad hoc commit because it was not coming from Git. And then we have a Docker image and the command that was run on the machine and data inputs. Also, who created it, what was the duration of the execution, and what was the price of that particular execution. You also get quite granular information on prices over projects or particular executions or or machine types and so on. And this is something that can be quite complicated to manage if you're running any larger organization on top of cloud and want to keep track of your cost on the cloud. All right, looks like the execution is now done. So if we look at the logs, we can see that Walohi ran something on the some feature extraction on the data, and then what we then did was we saved the data set into a folder on the machine that is Walohi-outputs. That's a special folder. Walohi detects all the data that comes into that folder and will automatically save that data into your data store. So what we've done is saved the data set into an S3 bucket, and we're then able to utilize that data for any future executions in Walohi. So I'm going to show that now. So we're going to take this data that we processed, and then we're going to use that for training. So I'm going to create a task, select the training step, and instead of the default values of the data, I can search for data. So I'm going to look for training images. You can see it's the output of the execution number 5 that we just ran. We're going to take in training labels, test images, and test labels. So now what we're doing is we're taking in the output of the previous execution as the input of the next execution. We can also do hyperparameter optimization. So here, for instance, I'm gonna do a quick grid search, but we also provide support for random search and Bayesian optimization. And I'm gonna enter a few different values that Walohi needs to look into. And this will result into a total of 9 executions. And when I click create task, Walohi will spin up multiple runs and run them in parallel on multiple machines. So here I have access to more than 9 machines, it seems like. So Walohi will be running this in parallel on 9 machines. We can also get real-time data and metrics from the executions. So here, for instance, we can start looking into how the accuracy is developing. Looks like this one is not so good, and these two are clustered up quite close to each other. So we could then start looking into like how the different hyperparameters affect our accuracy. You don't also have to track just accuracy. The way you track metadata in Walohi is by actually just printing your metrics into stdout, and because of this, you can utilize any library and you're able to track any metric that you want. And it doesn't have to be just one metric. You can have 100 different metrics tracked in Walohi, and they will be shown on the metadata tab. All right, so let's then look into deploying the best performing model here. So I'm gonna select the model with the best accuracy. So here, let me organize these. All of them haven't gone through, but I think we're fine with running execution number 13. So what we've done here is we've saved a model.pb file. And what Walohi allows you to do is deploy models on an auto-scaling Kubernetes cluster as a REST API. So it enables you to really easily run models on REST APIs without having to think of all the complexities of something like Kubernetes. You just have to provide a simple wrapper for your model that exposes it. I'm not going to go into the technical details of how to do that, but there's plenty of documentation on our website if you're more interested into looking into the tech details. But essentially what we do is we select a target cluster. In this case, it's our public cluster. And we can create versions for those deployments. And then for that, we can select a output. Here, I'm going to take in the model number 13 that we generated in the hyperparameter optimization and decided that this was the best one. And when I click create version, Walohi will deploy the model into this endpoint. Another cool thing we have done is created aliases. And this really enables you to quickly iterate with your business applications that are consuming your models. So what we have here is the ability to do something like production, testing, and just essentially create multiple aliases. And what this will do is create a URL, base URL of your REST API dash production or base URL dash testing. And what this will do is those URLs will point to different versions of the model. In this case, we can see that we only have first of all, a single version running, and both of these endpoints are pointing to the same model. But if we want to now deploy a new version of the model, so let's say we want to deploy this execution number 9 model, we can do that. And then if we wanted to run it against our testing endpoint, we could easily switch it back to the new version. And what this will do is now enable you to sort of hide this all in behind a microservice that you can manage without having to think too much of the technicalities. And now you can start running testing. You can also create canary testing or A/B testing using this this feature. So you can have multiple aliases like the A model, B model, C model, and so on. We also provide simple monitoring for these endpoints, but I'm not gonna go into that because it would make the overview quite long. But again, we provide a lot of additional information on our documentation. So feel free to go there or then book a demo with us. I will additionally show you 2 more things. First, because we've tracked everything and built this sort of data catalog and saved all of the executions that we've done, what we can enable is this traceability of all of your code and all of your data and all of your endpoints. So every single feature or part of Valohai has this trace function. And when I click this trace button, what Valohai will do is it will build a lineage graph of the artifact that you are tracing. So here I have the predict digit endpoint that I enabled. And we can see that it's using this model.pb file that came from execution number 13. Looks like execution number 13 is using this data that came from this execution. So now you can imagine if all of this is running automatically as auto training pipelines and something breaks after 2 months of you touching into the pipeline, it's really easy to go to that endpoint and then start looking into like, how did this endpoint come to be? What were the executions? We can jump into the execution, start looking at the logs. We can get all the data inputs, here the inputs and also the outputs. So if we want to start looking like, did our data maybe break somewhere upstream, we can easily go there into the upstream and then get that data set and really know what was the exact data set that was used to generate this endpoint, or what was the exact code that was used to generate this. All right. Lastly, I will show you pipelines. So here we've been individually like running first the pre-processing and then running the training manually and then deploying manually. But all of that can be tied together into a pipeline in Valohai. So we can, in the YAML file, create a definition of how these steps work together and how they are deployed. So here I have a pipeline that starts with pre-processing, then starts 3 training jobs and then evaluation for those, selects the best model, and then finally deploys that. And when we click create pipeline, what Valohai will do is it will start running first the pre-processing, then automatically use that output data as input for these trainings, and then do the evaluation of finding the best model and then deploy it automatically. You can also schedule these, and like I said in the very beginning of the demo, everything is accessible via APIs. So let's say we want to generate this pipeline or run this pipeline from an API. It would be just a matter of copying this API call here. So we make it really easy to get these API calls. Of course, we also provide a full documentation on the API, so you can use that. But for the most common things. We also provide a easy, just copy-paste API call. Hey, that's it for Valohai. If this is something that's interesting, I recommend you book a demo with us. We are happy to talk and spend a few minutes exploring what your problems are and if Valohai can be a solution for those. Valohai can be run in your cloud or our cloud, so your data is always safe, your code is always safe when you're using Valohai. And additionally, we provide a free of charge, no commitment, 30-day free trial for Valohai for all of our customers, so you really get to experience it before having to make a decision. Looking forward to hearing from you. Thanks for your time.